Hey guys, this is ExamHelp, and I'm just going to go over what's called composite functions. So I'll just write that down there. Composite functions. So what is a composite function? Well, composite just means made up of. So a composite function is a function which is made up of two functions basically. So you can have a function, let's say f of x is equal to 3x plus 4. And then we could also have another function called, let's say, x squared. If I wanted to do g of f of x, this is what's called a composite function. So this would basically be, you would get your f of x and you put that in to here instead of the x. So you get your g of the function f of x. So you're still doing the function, so g of 3x plus 4. So that then goes to 3x plus 4 squared. So basically, wherever you see an x in your g of x, you would put the f of x function into that space basically. So this would then go to 9x plus 24, 9x squared plus 24x plus 16. So that would be g of f of x. If I was to give you another example, which you can work out yourself, question 1, if I said f of x was equal to 2x plus 2 and g of x was equal to 3x plus 3, I want you to A, find f of g of x, and then B, we'll just do the opposite. So B over here is g of f of x. So as you can see, I would have previously done it in square brackets, but we can also write it just like that. So I'll let you work those out. Okay, now, so let's find the f of g of x. So we want to find f of 3x plus 3. So remember, wherever we see the x, we put this. So that is equal to 2, 3x plus 3, and then plus 2. So that will give us 6x plus 6 plus 2, which is 6x plus 8. That's an 8. Okay, so g of f of x, g of 2x plus 2, and that would be 2x plus 2, and then plus 3, which will give us 6x plus 6, and then plus 3, which will give us 6x plus 9. So, from these results, we can actually see that the two answers we got were actually different. So, we need to make sure, we need to know that we can't just interchange these around. So we can't just go, oh, we want to find f of g of x, let's just put g of f of x because it's easier. It would give a different value, so we can't actually do that. So we've got to make sure we put it in right. So with composite functions, we can find the domains of composite functions. Well, we need to consider a function. Okay, so if we had x, and then first we did g to it, so we did whatever g said basically, we get g of x, and then if we do f to that, we get f of g of x. So we need to make sure that we know that. So if we were to do f first, then I'm getting g of f of x. So if f, for example, was given as, so f of x was given as the square root of x plus 1, where x must be more than 0, and if g of x is given as 5 minus x, where x is any real number, we need to find the maximum possible domain of f of g of x. So we want to find max possible domain of f of g of x. Remember, we need to get that the right way around. So we're doing f to the g of x, basically. We need to solve the inequality g of x. So the range of g consists of only positive numbers. So let's have a look at this. G of x is 5 minus x, and if we want the range of g to consist of only positive numbers, what we've got to do is solve an inequality as so. So we want 5 minus x to be more than 0 because we want to be any positive number. So that then goes to 5 must be more than x, so x therefore must be less than 5. So therefore x must be less than 5 for this to work. Therefore, the max possible domain for f of g of x is therefore x must be less than 5. So that's just composite functions and working out the domains of that. That was ExamHelp. Thank you for watching.